Hello and welcome to R&D Mathematics. Today we are going to talk about distance between 2 points in the plane. In the plane. Now in our last video we learned about the Cartesian plane. Now let's say we have 2 points. It can be, those 2 points can be in any quadrant, right? Just to derive the formula, I am writing those 2 points in quadrant 1, but it can be in any quadrant. Let's say we have point A and point B. Point A is x1, y1. Point B is x2, y2. Now, we are going to find this length. Let's call it D. So, D is size of AB. Now, we are going to find D. Actually, let me first give you the formula. D is going to be square root of x2 minus x1 squared plus y2 minus y1 squared square root of it. Now this is what you need to remember, but let's see why this is true. It's always better to understand the reason why all these formulas rather than just memorizing those things. Now let me ask you a question. Let's do this. Can you pause the video and think about this and tell me what are these two lengths? This length is x1, right? As a length, it's x1. That's what it means. This point is you go x1 units to the right and y1 units to up, right? That's in our previous video, Cartesian plane. So this length here is y1. Similarly, we use a different color, about green. So what about this length? And what about this length? That green color two lengths are x2 and y2, right? That should be clear. Now, what I'm going to do, I'm going to extend this line. So it will create this nice triangle, not just a triangle, right angle triangle. Now let me recall you something. So let me recall you something from school geometry. In any right angle triangle, let's say these are the famous letters A, B, and C. In any right angle triangle, we have this nice relationship that is known as Pythagorean theorem by the guy Pythagoras, right? Now we can apply this into our triangle. But before that, you have to identify the length. So one length is D. That's what we need to find. Other two lengths are, okay, let me use color white, these two. Now what are the lengths of these two? For example, this one right here. What is the length? Let me call this C. So what is AC? The length of AC. That's going to be, if you think about it carefully, the length from this length right here is x2 and this length x1. So that is AC is x2 minus x1, right? And similarly, BC is going to be y2 minus y1, right? Now when I use Pythagorean theorem, I get d squared equals x2 minus x1 whole thing squared plus y2 minus y1 whole thing squared, right? And when I solve for d, square root of x2 minus x1 squared plus y2 minus y1 squared. See, we got this formula. That's where and how it comes from. Now let's see some examples. Now, How about if I ask you to find the distance between -3, 7 and 5, -2. Yes, you can draw it, but you don't have to. But since this is the first example, let's see roughly 1, 2, 3, somewhere here, and 1, 2, 3, 4, 5, -2 somewhere here. So something like this. Okay. Now what you need to do, you need to first label x1, x2, and y1, y2. Which one are you going to choose as x1, x2? Is this one or this one? Well, it doesn't matter. So x1, y1, x2, y2. Now D is, now let me go to the previous page. D is a way of remembering x difference squared plus y difference squared, right? So x difference, x2 minus x1, 5 minus -3 squared plus y2, here y2, x2, y2 minus y1, so -2 minus -7 squared square root. So you have to be careful with minus sign. 5 minus -3, that's +3, so 8 squared plus -9, put a parenthesis squared, because see this number here is always going to be positive. This is always going to be positive. So this is actually 8 squared plus 9 squared, because minus into minus becomes plus. So you get 64 plus 81, square root of that is square root of 145. Let's leave it like that for the time being, and let me address few things in this formula. Now what if you choose your x2 and y2 in the other way, other than using, what if you choose this guy x1, this guy y1? So this is x2, this is y2, this one. Now x2 minus x1 is going to be the other way around. So let's see, -3 minus 5. Earlier it was 5 minus -3. Now the other way around. And y2 minus y1, 7 minus -2. Let's see what's going to happen. Now you have -8, everything is squared. And here 7 minus -2, 7 plus 2, that is 9, 9 squared. But -8 into -8 is 64, or it's same as +8 squared. 64 plus 81, see, it's the same thing. So remember, it doesn't matter which minus which, but something that you have to remember, if you go with x2 minus x1, and for your y's also you do that, well, again, because we are taking a difference, it doesn't matter which order you go, but as a practice, it's better to, within x1 and y, x2, if you call this x2, and you must call the other partner, other guy, as y2. That's the only thing that you have to be careful with this formula. And we can use this formula for many different problems when you talk about parallel lines, and this formula itself is not that hard, but this can be combined to create a nice tricky problems, and we'll see those things in a later video. Thank you.